Hello, and welcome to this quick presentation on software engineering and why it's important to you as a college CS major. Now, software engineering is such a key component of the CS degree, and I feel like it gets overlooked a lot. Um, there's such a big focus on programming and many different aspects of different languages and methodologies and ideas that this one can sometimes get a little bit overshadowed. This is such a core concept to your future and what you'll be doing in industry that I hope you take away some principles here that will help change the way you think about your programming and how it will make you a better software engineer, regardless of whatever role you end up in the future. So let's talk a little bit about what is software engineering and what it means for you in the future. So, software engineering is the application of engineering principles to the design, development, testing, and maintenance of software systems. Now, these principles cover the entire life cycle of an application or piece of software, and this is not just programming. I know it can very well seem that way through many of the lower division courses you've potentially taken, and with a lot of the projects and things, sometimes that's just like the main thing. It's, oh yeah, I'm going to write this piece of code. I'm going to do this. But there's so much at the beginning and end of the software engineering train that gets overshadowed when you just focus on that topic. So now I know this is a little contrary to what I've just been talking about. Some key principles of software engineering do have to do just corely with your programming practices and how you're going to be implementing your code and software. And so we are going to start there. But as we go on through this presentation, I hope you keep in mind that how you're going to implement this into not just the programming portion of a life cycle of an application, but throughout the entire length of the project. So let's start off with the solid principles. Now, these are just 5 really good software engineering principles to be aware of, and that if you integrate into your everyday use, you'll see yourself increase as not only a programmer, but a software engineer. So the first is a single responsibility principle. Now, this means that a class should only have one reason to change. Second is the open and closed principle, that software entities should be open for extension, but closed for modification. The third is the Liskov substitution principle. This means that subtypes must be substitutable for their base types. Fourth, we have the interface segregation principle. Now, this one is very important. I hope you take note of this one, because if you don't follow this one, you're going to run into a lot of problems down the line. That is that clients should not be forced to depend on any interface that they do not need to use. So again, remember that for future development. The last is the dependency inversion principle. So when you program something, remember to have it depend upon abstractions, not concretions. A few more principles that work really well with software engineering are modularity. So remember to break your software into smaller and independent components. The larger and more complex you make something, the more likely you're going to run into complex issues and bugs down the line, and you're going to kind of forget how things worked, and it's just going to make a mess. So if you keep things simple and small, it will make your program more efficient and easier to read, especially if you're working in a team. Another great item to put in your toolbox is abstraction. It allows you to hide the complex reality of an object while exposing only essential features. Another great item to use is encapsulation, and it will allow you to bind data and methods that operate on that data within a single unit and restricting access to the object's internal state. Now, these last 3 are just kind of some fun principles to keep it light, but also they have some really great information contained within them. The first is the KISS principle, and that is just keep it simple, stupid. Just remember, favor that simplicity in design over complexity. The more complex you make something, the more likely you are to run into complex issues, and it'll just run better if you keep it simple, and it will be less complicated to troubleshoot and for other people to use. And another great principle is the DRY principle. And that means don't repeat yourself. Remember that every piece of knowledge must have a single, unambiguous, authoritative representation. So if you're going to have something happen like 3 different times, don't write that code 3 different times. Have it written once and be called in those times. So have one-offs for each thing. Don't keep repeating yourself. That just adds unnecessary complexity. The last is the Yagami principle. Avoid adding functionality until it is needed. So remember, if you aren't going to need it, don't put it in. That is just a great piece of advice. If you have something that's going to be needed 3 months down the line, put it in 3 months down the line. Don't put it in now. You'll confuse yourself and other people that you're working with. So now I know we've been talking about these principles, these programming principles, and now we're going to talk about how these fit into a software development lifecycle. We want to take these ideas and combine them in there. So first off, we're going to talk about the software development lifecycle, what it means, and some different ways that we can work through it. So the software development lifecycle we've put down into 4 key fields or steps at the time. Now, as you get further into your career and further into various CS programs, these might divvy out, become more complex, but for now we can just worry about these 4 steps. The first is the design step. This is the initial step in creating a piece of software. This covers what the goal of the application will be, what it will look like, and who it will be made for. So this is really important. Again, a very, very important step in whatever you are doing. Software cannot take off. You cannot just sit down and start programming without a design step. If you do, you're going to find some pieces are missing and that the software will not do what you need it to do. The second step is that development step. It is the part we're all familiar with. This encompasses the creation and programming of the application. So, very fun step. I've always enjoyed this one myself. The third step, this is another very crucial step. It is the testing step. While I know some testing is done during development, most of the testing will happen post-development, and it is utilized to polish out any of those remaining bugs or unintended features. And it is also used to make sure that the application runs as intended. Now, if you don't do good testing, users are going to find bugs and exploits in your software, and we do not want that. We want the software to work as intended. And so that's where this testing phase is so important. And then finally, we have the maintenance step. And this is after an application is completed, it still may require some support to run with any software upgrades or technical changes in the future. This really helps the application last for years to come after it has been created. So next, we're going to kind of talk about a little bit more of the software development lifecycle, but a couple of methodologies that are used to complete these steps and how you can use them to become a better software engineer. So within the software development lifecycle, the 2 we're going to talk about today, the 2 methodologies are the waterfall methodology and the agile methodology. Now, the water methodology is a more linear approach where each step is completed before the next. Kind of how that list was. We work from top to bottom. We go from design to development to testing to maintaining and deploying that software. This is great for milestone tracking, and it works really well with well-defined projects. The agile methodology is a more of a cyclical approach where we're going to run through each of those steps over and over and over until all of the steps are completed. This allows for a very quick turnaround time, and this method is also most commonly used in industry. So I guarantee you will see this methodology at some point in your professional career. So we're going to go ahead and talk a little bit more about the waterfall model right now, and let's talk about some of its pros. So again, it's that linear step-by-step approach is such a key pro to this methodology. It's easy to manage. Your milestones are very straightforward. And for budgeting and business side, we've got a fixed timeline and a budget to attach to this, saying we're going to spend X money on design, X money on development, and so forth and so forth. So this is very good for stable projects that aren't going to have much corrections or change with it. If they're ready and defined and ready to go, the waterfall method is great for those projects. Now, there are quite a few cons with the waterfall model. The fact that it is so rigid and doesn't lack flexibility can give it a lot of problems throughout a software's life cycle. This inability to easily accommodate change can be costly and have very high prices associated with it, along with with how the structure of the waterfall method. Customer feedback can be quite delayed, and when you get some feedback, you might have to take a couple steps back and change some things back into development. And the same thing can happen once you get to the testing step. If you find some really critical issues or functionality was left out or missed, that can be very costly to send that back to development, and especially when that budget had already been set out. So those are some major cons to the waterfall method. But it is, again, still a great method to use in software development. The second, again, this one is a bit more used commonly. It is a bit more concrete and has some better functionality to it. That's the agile model. Specifically, this infographic I've got on here it's very representative of an agile method called the Scrum model, where we're going to create milestones or iterations of different items we want to get accomplished with each iteration. And within those iterations, we're going to define tasks that we're going to complete, that we're going to do the full model on of design, develop, and test. And then with each of those iterations, we're going to check all those items off and then move into the next and into the next and into the next until the project is completed. This really allows for increased adaptability for if any wrenches are thrown or changes are requested through the life cycle of the project. They can be easily implemented into the different iterations, and the project can just continue on forward. We've got really fast time to market because of this. With close collaboration with clients, you can constantly get feedback on each of those steps that are completed, and that just allows the project to move so much faster and is just a lot more streamlined. Again, so better collaboration and communication, not only with the client, but also within an internal team that you have is very optimal with this. And this reduces the risk of errors through client communication, internal communication, and it allows for that continuous improvement within each of those iterations. That even though we might have an item completed within another iteration, we could also improve on some features of past iterations. Nothing is locked behind a wall like the waterfall model. It's everything is free game to change and to push through each of those iterations. Along with that, with the constant communication with both internal and external teams, there is high team morale with being able to see the product move forward and different items be completed. This really boosts the work ethic for those involved with this project. Now, obviously, the agile method is not without its cons, which we'll go ahead and get into now. A big one is the lack of predictability. With so many iterations and different changes and things that can come, we have no idea. We cannot project how many iterations a certain piece of software will take. These are also very susceptible to scope creep with the many different iterations and client input and team input. Sometimes too much of a good thing is a bad thing, where we have so many corrections or ideas that get put in, the intentional path of the software can be lost. So it is really important within the agile model is to maintain scope and to not let the project get sidetracked. Another big con is the unpredictable budgets of the agile model. Because we don't know the length of the project, how short or long it will be, we can't really put a set budget to these. And that can be a little bit tough on the business side. Along with all the different cycles and steps, there is a big overhead on tracking the tasks, the various team meetings that go along with the Scrum method, and the many different roles that the Agile method often implies and requires for the team members involved in it. So again, this requires very specific skills, and if a team doesn't have all those necessary skills, oftentimes the Agile model will fail. So, but that's also a strength that when you do have all of those key components and key roles within the model, it will be very successful. And the last kind of flaw of the agile model is it's very, very dependent on customer input and working very closely with the client. Now, if you have a quick responding client, that can be a great thing, but also can be negative if they are constantly requesting changes and that again kind of gets back into that scope creep where a client themselves can actually derail a project if you're not careful. Or you could also have on the other end of the spectrum where you're getting no customer input and you're struggling to get that, and that can really halt up a project in the agile model, especially if you're requiring client checkoffs for each of those iterations. So as we come to the conclusion of this little presentation on software engineering, the software development lifecycle, I hope you've learned something today and something that you can take into your application as a CS major and into your career as well. You can remember that software engineering principles are key to understanding good business practices, and that a correctly picked development model and the development lifecycle model will increase your efficiency and success. Again, remember, software engineering is not just programming; it is every core aspect of development of a project, from the design phase to just the maintenance. And my best solution, or my best suggestion for you today as well, is to remember that communication and good engineering practices will make you successful. And so I just wish you luck as you continue through your education and into your career. And I hope you have a great rest of your day. Thank you.